Hey students, welcome back to the channel. Today we are going to see about to increase our next level of our perception on waves. So in this chapter you are having weightage of two questions from both NEET and EAMCET examinations. Waves, you can expect two questions from this one. Some of the basic concepts we are going to see about waves equation and some of the basic things on what you mean by stationary waves, or even we call it as a standing waves. According to this we are going to see this one. You people, you just concentrate over here. We are going to unlock the next level of our potential on the waves. In this one, two questions is most important. If you are really like this one, you just put your comments on the comment section. You please subscribe the channel so that you can get a recent update. People can subscribe the channels first. We'll see the questions one by one now. Hope you will enjoy the sessions. Welcome you all once again. First problem on waves is this one. See, which of the following represents a simple harmonic progressive wave? See, simple harmonic progressive wave. See, according to the equation of plane progressive wave, see, I can mention here. Say, for example, in the first case, y is equal to f of, see, this is about f of Vt minus kx. So even you can mention this one. V is about velocity, even angular velocity also mention over here. Vt minus kx, or even you can mention here as f of Vt minus x. So this one is along. So this one, the progressive wave which is along positive x direction, right? Okay, now next one. In this case, similarly here, if y is equal to f of Vt minus kx, here is you can mention like plus kx or even plus x. This will be along. So this is about the progressive wave. This will be along negative x direction. See, similar in this case, how I can mention here is, see, this is about x and y axis over here. This is x axis and this one here is y axis. Now in the first case, I can mention here, see, this is about the wave, progressive wave, which is moving along positive x direction. The similar over here, even you can mention this will be moving along, this is moving along negative x direction. So this is towards negative x direction here. So this one is minus x over here. This is moving towards the negative x direction. So in that case, you can mention over here. So what are the things will be there? So the first case, first option here is a equal to, see here, a equal to a sin omega t and cos x. So if both are, what you mean by sine wave and cos wave? First one I just mentioned here. In this case, for example of sine theta of value sine wave, how it will be forming over here is, I just draw and show you over here. See, along positive x axis here is, this is 0, this is 1 pi by 2, and angle, this is 2 pi by 2, 3 pi by 2 and 4 pi by 2 here. See here, sine 0 here is 0, sine 90 is 1. So this is about a peak, maximum peak. This is value, amplitude here is 1, and a sine, this one 2 pi by 2 here is, so this is pi by 2, 1 pi by 2, 2 pi by 2 here is pi, 3 pi by 2, this one, that is 270, 4 pi by 2 here is 2 pi. See, sine 180 here is 0 here, and a sine 270, that value here is minus 1. And again you can mention here this one, sine 2 pi here is 0. This is about sine wave. Similar concept, in that case you can mention here, this is about cos theta over here, cos of angle, cos wave, you can mention similar like this. See, this is about positive x direction, this is 0, and 1 pi by 2, 2 pi by 2, that is 2 pi, 3 pi by 2 here, and 4 pi by 2, that is 2 pi, right? Now what is cos 0? Cos 0 here is 1. So this is about maximum amplitude. Cos 90 is 0 here, and see here, cos pi here is minus 1 here, and cos this one 270 is 0, and this one here is cos 2 pi, that is cos 360 is plus 1. So in this case, this is about the cos wave, and this is cos wave, and this one is sine wave. See, according to this, So progressive wave, which is moving towards the positive x direction or even negative x direction. In this case, you can mention over here. So in this case, answer here is this one. So whether it may be a sine wave or cos wave, so it should be a traveling wave. Then the wave is always called as simple harmonic motion or even plane progressive wave. So answer in this case, this one. Problem here. A transverse is represented by an equation y equal to this one. You can see the same in the previous one, a sin omega t minus kx, and the measurement of the distance are in meter, then the velocity of progressive wave. So general one, velocity. In that case, you can understand here. Before going to that, I will show you the formula for this. See this one, you can understand here. See, wave velocity here is the distance traveled by the wave in 1 second is called as wave velocity. So according to the wave velocity, velocity is equal to lambda by t. How you are getting this formula here is, I just write down and show you here. See this one, frequency formula, nu is equal to, see, hope you can understand here, nu is equal to c by lambda. C is about velocity, lambda is about wavelength here. And this one, again, nu is about frequency, 1 by time will be equal to velocity divided by wavelength. See, from this one, velocity equal to, see, from this one, you can understand how you are getting this equation here. See, now I will show you in this case. From here, velocity will be equal to omega divided by k. Now, see, similar concept in this case. In the previous one, how you can mention here is, for the progressive wave, y is equal to a sine this one omega t minus kx here. Compare this one to the questions what they have given. From here, this is the equation, general equation. From the questions what they have given here is 2 sine of 30t minus 40x. See, from this one already we know that formula here, w is equal to omega value. From this one, omega here is 30 and k value here is 40. So this one here is omega here is 30 and whole divided by 40 here. 0 and 0 will be cancelled here. So that is 3 divided by 4, that is about 7, 428 and 5. So this one, wave velocity here is 0.75 meter per second. So answer in this case. Here, see, the equation of a transverse wave traveling on a rope is given by, they have given the traveling wave, that is about the progressive wave with y and x are in a centimeter, t is in a second. The maximum transverse speed of the particle in the rope is, so they are asking about speed here. Now in this case, you just compare this one is the equation here. See, y is equal to a sine of, see this one, pi they have given, this one along with this a sine of kx minus omega t. According to this, you compare the equation what they have given, y equal to 10 into sine of pi, you just multiply inside 0.01 pi of x, and even omega t here is minus 2 pi t. Now in this two equation, from first equation and second equation, so omega value here is, so you can compare here, omega is equal to 2 pi and a value here is 10 here. Now in this case, see, from here what they are asking here is speed. V is equal to, V here is r omega. In this case, you can mention as a omega, or even you can mention as v is equal to a omega, or even this one r omega. Hope you remember this one. According to this, a is about the amplitude here. From this one, v is equal to, a value here is, a is equal to 10 over here. So 10 into omega value here is 2 pi. Now this one here is 10 into 2 into pi value here is 3.14 here. Now that one, 10 into 6.28. Now if you multiply here, that value here is 62.8 meter per second. So in this case, answer here is, now this one they have given in centimeter, so that you can mention here centimeter per second. So answer in this case. Next problem, this one old question paper problem here. So the angular frequency of a particle in a progressive wave. Now this one, this is about the progressive wave in an elastic medium. So omega value they have given, that is 100 pi. It's moving with velocity. Velocity value they have given, that is 200 meter per second. So what they are asking here is the phase difference between the two particles separated by a distance. If the two particles which are separated by a distance, they have given 20 meters. So what is the phase difference? Now, for example, what is the relationship between the wavelength and the phase angle here is this one. A small change in the phase angle you can mention as del phi. So the total angle here is, that is 2 pi here. And a small change in the distance here is del x. And the wavelength here is lambda. See, from this one, del pi is equal to, so what they are asking here is del pi is equal to, that one you can mention here, 2 pi by lambda into del x. Now, see, from here, del x value they have given, this one you know, but you have to find out what's lambda value. Now, if you know this one, you can substitute the value over here, you can get what is del pi. Now, if you want to find out the wavelength lambda, what is value lambda here is, from this one, what are the data they have given? Omega value they have given, that is 100 pi. That is a radian per second they have given here. And next one, velocity, what they have given, velocity here is 200 meter per second. This is this one here is radian per second, and this one here is meters per second. See, this is angular velocity, and this one is about velocity here. Now, in this case, from here, omega is equal to, omega here is 2 pi into nu. Now, from this one, new value from here, see this one, omega is equal to 2 pi nu. Nu is about the frequency here. Omega value what they have given here is 100 pi into 2 pi nu. So this one pi will be cancelled here. See, from this, nu is about frequency. Frequency is equal to 50 hertz. Now what we got here is frequency value. Now from this one, what we are going to find out here is lambda value. According to this one, see, nu is equal to, frequency is equal to velocity divided by wavelength. From here, lambda is equal to velocity divided by frequency here. Velocity value what they have given, that is 200 meter per second, and frequency what we got here is 50. From this one, if you find out the wavelength here is, what we got here is 4 meter. Now we got wavelength value here. See, from this one, del pi is equal to 2 pi divided by 4 is the this one wavelength here, and del x value they have given, you can see this one, del x value here is 20 here. Now you just multiply with the 20 meters, so what you are getting here is 5. 5 into 2 here is 10 pi here. So this one here is, in this case, you can mention here 10 into 3.14. So what you are getting here is 31.4. That is about phase angle. So 31.4 here is radian. So answer in this case here is problem here. A progressive wave moves with velocity. So v velocity value they have given, that is meter per second. So which is in a meter per second. See here, and the frequency value they have given, that is 200 hertz. The phase difference between the two particles separated by a distance. So they have given two particles that having a difference they have given, that is 1 centimeter. So is what they are asking here is phase difference. See, according to this one, this is about the formula here. See, phase difference here is del pi. Remember this one always, del pi, this is about angle. The total angle here is 360 degrees, so that is 2 pi. And the distance, small change in the distance they have given, del x. The total here is about the wavelength. See this one, see, from this one I just mentioned here. So this is about one wavelength. That is, you can mention this one from here to here. Wavelength value here is, you can mention this one, that is lambda here. Right, this is about wavelength. From the small distance you can mention here this one. See, in all the cases, this is 0, this is pi by 2, this is pi here, and this one here is 3 pi by 2, and this one here is 2 pi. Right, say for example, from here to here, what is the distance I just mentioned as del x. So what is the phase angle? 0 to pi by 2 here is phase angle. See here, pi, del pi here is pi by 2. Right, you can easily find out this one, del x. See, del x means, see, this one here is 1 del x here is, you can mention this one lambda by 4. So this one here is lambda by 4. Again, from here to here, again one more lambda by 4. and the last step is lambda by 4. There is 4 lambda by 4. The total value you can mention this one, that is lambda here. For example, you just use the same formula in this one. For example, del pi phase difference you are going to find out here, that is 2 pi by lambda into del x. If the if this one both the distance between the waves, say for example one wave I just mentioned here, see one wave which is starting from this side, right, another wave which is moving from this side, for example you just consider in this case which is moving from this side. So this is about the common point. So here if you find out the distance between this one, see for this angle and for this one, if you find out here what is the distance between these two, you can mention this one, this is lambda by 4. For example, see here, distance here is lambda by 4. What is the phase difference between these two here is lambda into distance del x here is lambda by 4 here. So this one will be cancelled. So what you are getting here is pi by 2. So del pi here is phase difference is pi by 2. So the phase difference between first wave and the second wave here is pi by 2. Similar concept here. From this one, see del pi is equal to del x divided by lambda into 2 pi. Now, see in this case, what are the things they have given? See lambda value, how you can find out the lambda value? Lambda value they haven't given, only del x value they have given, that is 1 centimeter here. 1 centimeter means 10 power minus 2 meter. Now del x value they have given, we have to find out lambda value. How you can find out the lambda value here? See, already we know this one, nu is equal to velocity divided by lambda. See from this one, lambda is equal to velocity divided by nu here. So velocity what they have given? So they have given 36 meter per second, and frequency how much they have given? They have given 200 Hz. That is about lambda here. Now you just substitute this value here. See from this equation I just mentioned here, del pi is equal to, see from here del pi is equal to 2 pi, and del x here is 10 power minus 2 meter whole divided by lambda value here is 36 divided by 200 will be here. Now you just simplify this equation. See this is 10 power minus 2 and this one will be cancelled here. So this is 2 into 2, that is 4 pi divided by 36. Now you just simplify this one. See from here this one will be cancelled for this one. So pi by 9 radian is the answer for this case. Hope you can understand this one. You just go through the steps. The steps can be used to find out the difference between the phase and phase angle and the distance between these two waves. Problem here. See this one. This is very easy question. See here. One small steps have to add in addition, but it's very easy. See here, the speed of the wave in a medium. So velocity they have given meter per second. If 3600 waves are passing through a point in a medium in 2 minutes, so its wavelength is. So now let me tell you. See this one. In this case, one particular point I just mentioned here. In one particular point, there are around 3600 waves are passing through 2 minutes, right? Now suppose if you want to find out the wavelength here is wavelength is equal to, wavelength here is how you can find out the wavelength here is, wavelength is equal to you can mention this one, that is about velocity divided by frequency. Now hope you know this one, frequency nu is equal to, according to photon equation, E equal to h nu. Hope you remember this one, E equal to h nu. From here this relation nu here is c by lambda, so h is c by lambda. According to this concept, so this relation here, see from this one, frequency nu is equal to velocity divided by wavelength here. From this one, wavelength will come over here, velocity divided by frequency. See, according to this, you are going to find out here, wavelength is equal to velocity divided by frequency. Now, how you can find out frequency? Frequency, another relation here is, frequency is inverse of time, right? See, that is per time. So, according to this one, what they have given here is, see, 3600 waves in in, so 2 minutes means 120 second. See, now from this one, how many waves? There is only one number of waves here is, so there are in 120 second means one number of waves. How you can mention here is, so wavelength is different here. See from this one, so 3600 divided by that is about 120 seconds. So if you mention this one according to this, so what you are getting here is number of waves per second. So that's what you are going to have. See from this one, wave per second here is the same concept you can mention here. In this case, frequency is equal to waves per second. That is about frequency, right? Now this one, so in this case from here frequency, how you are getting that frequency here is, so frequency is equal to 360 divided by 12. Now if you cancel this one, what you are having, that frequency here is f is equal to 30 hertz. Now you substitute the value here. What they have given, the velocity, that is 360 divided by frequency, what we got here is 30 here. Now if you cancel this one, 76 divided by 3. So what you are getting here is, this is about 2 times balance 1 here, and 5 times. Now from this one, the wavelength here is 25.3 meters. So answer in this case, this is important and a old question paper problem here. A wire of 9.8 into 10 power minus 3 kilogram per meter. Now kilogram per meter, in this case this is about linear density. Suppose kilogram per meter square means that is about area density, kilogram per meter cube means volume density. Now what they have given here is, that is about linear density. Linear density, in this case the symbol here is mu. So what they have given here is mu value, and passes over, now I will mention here, and passes over frictionless, this one frictionless tight pulley fixed on the top of the frictionless C. This is about the frictionless pulley on the top, which has been fixed on the inclined plane and makes an angle of 30 degree. So this one, it's make an angle of 30 degree here, and the mass is my M and capital M are tied at the end of the wire such that M is at rest on the plane. This one, M is at the rest on the plane, and M, capital M, is hangs freely over here. Now this one is hangs freely over here, vertically downward. The entire system is in equilibrium, and the transverse waves propagate along the wire with velocity here is, they have given the velocity 100 meter per second. Choose the correct option. Now for this one, in case of a transverse wave, let me tell you here, you just go through on this one. Velocity of the transverse wave along the straight wire. See what you mean by transverse wave, how this transverse wave will be produced along the straight line. See what they have given here is, now you just see, you just tied, see I just mentioned here, see in that case, see two strings which are fixed at the rigid end like this, which has been fixed over here on either side. Now you are going to pluck this one down and release it, so that it will be vibrating like this, up and down it will be vibrating over here. So once you are going to release over here, it will produce the transverse waves along the straight string, straight length of the string. Now see here, in this case what they have given here is velocity, you can find out with the help of V is equal to T divided by mu, where T is called a square root of this one. T is the tension, and this is about linear density. That's what I have mentioned here, mass per unit length. Now in case of mass per unit length, you can use this formula. This is about the volume, area into length, that will give about the volume here. Volume divided by length, length and length will be cancelled here, so that A into D only will be there. This is about mass per length. See according to this, you can use all this formula over here. T is equal to mg. So this is about the tension which is acting upward direction. See here, I will write and I will show you here. See this one, see in this case the tension which is acting here, this one. See once you are going to pull with the help of weight, tension will be acting upward direction, which is equilibrium. In this case, this one will be equal to capital M into G, because gravity which is acting downward direction. So T is equal to mg here. See according to this, According to this concept, you just utilize here. Now, let me tell you in this case. Now, what they are asking in this one, see from this one, mass, how you can find out the mass. Now, we are going to find the mass with the help of this equation. See here, I just write down here. So, velocity V is equal to, we just see that one square root of T divided by mu here, where T is equal to, so what we got here is mg sine theta, because they have given that angle mg sine theta here. Now, this one I just tell you here why we are mentioning only sine theta, not cos theta here. Now, this is about sine theta here. Suppose if you are going to find out the angle, see this one, this is about the resultant one which is along this direction. If the resultant one moving towards this side, if you are going to find out the angle towards this side, means that you are going to take in sine of angle, right? Suppose if you are going to take the angle this side, or even if you mention this one along this side here is, that is moving towards opposite to the direction. See, I just mentioned as this is pi, means you can mention this one as cos pi. So anyway you can use here, because here angle I just mentioned here. So I will mention and I'll show you here. Here that angle which is in this angle, this direction here. So we can mention this one as sin theta, and whole divided by, now whole divided by mu value, linear density already they are given, that is 9.8 into 10 power minus 3, this whole root. Now I just mentioned here whole root. Now we are going to find out what is m value here. Now in this case, m value, how we are going to find out the mass. See this one, in this case, see here, v velocity how much they have given here is, that is 100 meter per second, and a square root of m into g here is 9.8, and the sine of angle here is sine 30, and whole divided by 9.8 into 10 power minus 3. Now you just cancel it here, and sine of 30 here is 1 by 2. So here is square root of m divided by 2 here, and this one 10 power minus 3 will become 10 power plus 3, that is 1000 here. Now from this one what I'm going to mention here is just square on either side, so this will become 10,000 here, and the root will go, so m into, see here 1000 is there and divided by 2, this 3 cyber will be cancelled here. So from this one m is equal to, m here is 200 kg. So answer in this case, m is equal to, see this 3 cyber will be cancelled here, 3 cyber, so m here is 20 kg. Now from this one, answer in this case, important old question paper problem. A progressive wave of frequency, see 500 Hz, is traveling with the speed they have given. A compressional maximum appears at a place at a given instant. See, compressional maximum, starting from compressional maximum, the minimum time interval at which a rarefaction maximum occurs. See, from maximum compression to maximum rarefaction. Compression and rarefaction, where it will occur here is in this case of longitudinal wave. See, you just observe in case of a longitudinal waves here. See, in this longitudinal wave, see this is about the rarefaction here, rarefaction maximum, and this is compression maximum. See this one, red color you can see this one, this is about the compression, and blue color you can see this one, this is rarefaction maximum, and rarefaction compression maximum, this one. See, I just show you in this case. See, first one, what they have given in this case. See, they have given about frequency here, frequency nu is equal to 500 Hz, but next one, velocity, what they have given here is, that is 350 meter per second. Now what they are asking here is time interval. See, time interval, after which time interval, that is which rarefaction maximum rarefaction from maximum compression. Now that one will be equal to, I will show you here. See this one, in this case, see from this is for example we just consider here, this is about maximum compression, one maximum compression to another maximum compression. the total time period, you can mention this one. This is T here. So this one, this is about here. There are a 4 segment is there. See, from this one, you can see here, there are 4 segments. Am I clear? This is, see here, from here to here, one segment. From this one, another one segment. This is third segment. From here to here, fourth segment. The total here is T. T can be divided into T by 4, 4 segment. Right, T by 4, T by 4, and the last one is again T by 4. The total here is T, right? So what they are is asking here is minimum time interval at which, see, from maximum rarefaction from maximum compression. See here, this is about maximum compression here, maximum compression to, this is about maximum rarefaction. Totally how many we are having? There are two times of T by 4. So what we are having here is 2 times of T by 4 here is, we are having T divided by 2. So that is about T divided by 2. According to this one, inverse of frequency here is, inverse of frequency here is time. So from this one, time, how you can mention T is equal to, T you can mention like 1 by 2 into mu. So 1 divided by 2 into mu value what they have given, that is 500 Hertz. See, from this one, 1 divided by 1000, that is 1 divided by 1000 second, that is about time period from maximum compression to maximum rarefaction. So answer in this case. Next problem, this is quite interesting. You see here a wave of length, see, wavelength here is 2 meter, is superimposed on its reflected wave to form a stationary wave. First, how it will form a stationary wave? See, let me tell you here. First one, you just consider about a waveform. I just show you here. Now, this one, this is about one wavelength. Here is, this is about the wavelength. This one I just mentioned here. This is about lambda, right? On this one, this is about wavelength here. Once it is moving like this on the reflected medium. See, this one, this is lambda here. What they have given, the wavelength here is 2 meter. Now for this one, you can mention this one for this case. So here is one of that, you can mention this one, that is lambda by 2, 1 of. So here that the distance here is 1 meter. So lambda here is 2, you just substitute here 2 here. So what you are getting here is 1 meter. Now what they have mentioned here is, see, after reflected wave to form a stationary wave. Now after reflecting here is, now it is forming reflected waves which is forming a stationary waves of the same wavelength. See, both are same here, but I couldn't draw this one, I just show you. Now in this case, you can see this one, this is about node, and again this one also node here, and this one also node, and in this case this is about anti-node, and here is again anti-node. So what they are asking here is, a load is located, now a node is located at x equal to 3 meter, that is this one. See, first one is, this is 2 meter here, so that is 1 lambda, and the next node again it will be forming here, right? You can see this one node and second node, this one, the node is formed at the first one. After reflection, the node is formed in 3 meter. Now next one, the next node will be, see, this is I just mentioned here. See, in that case, see, I just draw and show you in a different form. So this is after reflection. See, this is reflected one. This point it will be reflected. After reflection, the node will be formed in 3 meter. That means this is 1 meter and this is 1 meter. After reflection, one more 1 meter. So total here is 3 meter here. 3 meter. What you are getting here is one node, right? After reflection, the next node immediately, the next node when we are going to have next node. So here is, so this one 1 meter you got. Next, this is one node is over, right? Next node you are getting over here, that is this direction. This value here is 1 meter. So that next node will be 3 meter plus 1 meter, that is next node here. So answer in this case 4 meter. So answer here is 4 meter. Okay, the next problem again. This is important here. See this one. Yeah, stationary wave. See here, a stationary wave of y is equal to, they have given the equation here. Y is equal to zero point 0.8 cos of pi x by 20 sine of 200 pi by pi t here, where x is in a centimeter and t is in second. The separation between two consecutive nodes. So what they are asking here is the distance between the two nodes. Now for this one, see here, first what I'm going to write on here is, for in case of a standard stationary wave equation, stationary wave equation I just mentioned here. See, for this one, a standard stationary wave equation, that is a sine omega t minus kx, that one formula is there. Another one also, that some of the basic formula here is a into cos of 2 pi x divided by lambda here, and sine of the same one 2 pi nu t, or even velocity here, divided by lambda. Now in this case, from this one, comparing this equation and what they have given in that equation I just mentioned here, 2 pi x divided by lambda, that one will be equal to what they have given here is pi x divided by 20. Now from this one, see here, pi x will be cancelled here. So from here, lambda by 2 is equal to 20. So from this one, lambda is equal to 40. Now, so what they are asking here is the separation between lambda we got here, the separation between two consecutive nodes. See this one, all the values here is in x in centimeters, so the wavelength is in centimeter. See, for this I just show you. See this one, this is about stationary wave or even standing waves you just mentioned here. This is one wave, standing wave in this case, which will be moving towards like this. See this one, the total wavelength in this case, what they have given the total wavelength here is, see this one, this is about the wavelength here, lambda value. This is about lambda here, right? Now from this one, lambda value here is 40 centimeter, and what they are asking here is the separation between two consecutive nodes. So this one is node, this one is node, again this one is node, and these two are anti-node. See, I just mentioned as this one, as I said in a previous problem, this is about anti-node. So two consecutive nodes, see this one up to from here to here, or else from here to here. So the distance between here is distance between, or even a separation between two consecutive node here is, you can mention this one, that is lambda by 2. So lambda value we got, that is 40. 40 divided by 2 here is 20 centimeter. So answer in this case. Thank you so much for watching and your patient listening. If you found this helpful, don't forget to like, share and subscribe the channel for more updates. See you in the next one on waves 2, especially in case of speed of traveling waves. You just subscribe the channels, all the updates will be updated immediately soon to you, your YouTube channel. Thank you.